This is truly amazing. The hydraulic piston rod, which was bent and considered broken, was repaired and restored by a Pakistani craftsman. The repair cost was only 2,000 rupees, and the bent piston rod could be straightened out forcefully. The hydraulic piston rod in front of us must have been valuable before it was bent, but the craftsman still regarded it as a treasure even after it was bent. They needed to heat it with fire, mainly to reduce the hardness of the piston rod through high temperature. This is to avoid the initial stress of the piston rod causing fatigue of the metal when the hydraulic press presses down during the repair. This can lead to cracking and failure. This is also why the craftsman used an oil-soaked cloth to heat the piston rod, since the piston rod is solid. To ensure that the area being heated is even, the baking process needs to last for half an hour. In this way, the temperature inside the piston rod will also increase. After the craftsman burns 20 strokes, the temperature of the piston rod reaches the repair requirement. In order to prevent the temperature of the piston rod from dropping, the craftsman needs to quickly place it on the workbench for repair while the temperature is still suitable for use with the hydraulic press. When applying downward pressure at the head of the hydraulic press, the craftsman must also monitor the timing to adjust the piston rod. This is because each downward pressure will cause a change in the damaged area, so the head of the hydraulic press needs to be checked to avoid secondary damage to the piston rod during the repair process. Since the outer diameter of the piston rod will also have some elasticity, the craftsman needs to lift the piston rod to ensure that even if there is elasticity, the desired effect can still be achieved. The most difficult part of repairing a piston rod like this is to handle the details. It not only requires readjusting the position of the piston rod, but also relies on past experience and visual judgment to restore it to its normal use state. As the hydraulic press continues to adjust, the craftsman can only measure the surface with a scraper. If the scraper jumps while rotating, it indicates that this area still needs downward pressure from the hydraulic press. This is also the experience gained from repairing 200 piston rods. Once it is confirmed that the piston rod is not deformed, repeated bending and stretching will cause the coating on the surface to crack and peel off. In order to ensure that the piston rod can be used normally, the craftsman must remove the original coating on the surface before starting the second coating. Using a high-quality compressed polishing brush, they meticulously treat the surface of the piston rod. During the polishing process, the craftsman not only needs to press the brush firmly, but also moves it at a steady speed. This not only removes impurities from burning and heat, but also makes it easy for the craftsman to check the surface. After the craftsmen have polished the surface, they need to mark the concave areas because these bumps can also be caused by the oil from the siline. Therefore, they can only use the brazing rods to rebuild the concave areas. The main goal is to fill the concave areas. Because the surface of the brazing rod is very uneven, in order to keep it consistent with the outer diameter of the piston rod, a layer from the brazing rod surface needs to be completely removed. Using an angle grinder for polishing makes the surface of the brazing rod smooth and flat. Because the conventional polishing discs leave a lot of marks, they need to be replaced with more delicate polishing discs. However, the angle grinder can only perform a walking operation on the brazing rod. After a simple treatment, the craftsman switches to a polishing wheel when pressing to ensure that all the round surfaces are polished. After all the dented areas have been repaired, because the coating on the metal parts has very strict requirements, the craftsman needs to repeat the surface treatment 20 times. This is not only to make the surface of the piston rod shiny, but also to ensure that there is no change in the surface finish. When the surface can act like a mirror, the piston rod can undergo a chemical reaction to reattach the coating. After gently wiping the surface with talc powder, the piston rod is immersed in the stock solution by pulling it up with an iron chain. This allows the piston rod to react with the stock solution and form a new protective layer on its surface. Since the coating will increase its outer diameter, this is also the reason to remove the original coating before proceeding with the coating. If the outer diameter increases, it cannot be used. Since they did not use acid chloride for degreasing, they needed to reprocess the outer diameter of the piston rod after completing the coating process. That is, they polished the surface again to ensure that the accuracy of the piston rod met the requirements of use. After polishing, the surface was wiped clean with talc powder again. Although there was no precise confirmation by micrometer, they could rely on years of experience to determine whether this piston rod was up to standard. Thus, the bent piston rod was successfully straightened. This was truly impressive,